Most teams think their AI agents are failing because the models aren't good enough yet. They're not. The model is fine. The problem is what the model doesn't know about your business. Build that layer, and the problem is solved. Teams spend months fine tuning prompts, swapping models, running evaluation after evaluation, and the agents keep giving the wrong answers. Not hallucinating wildly, just confidently, plausibly, specifically wrong. The model isn't the variable, the missing context is. Here's the failure pattern we keep seeing. A team deploys an AI agent, a real one built on a capable model connected to real data. They test it. It sounds good. They ship it. And then someone asks it a question about revenue, and it gives an answer that's coherent, well structured, and wrong. Because it picked the wrong definition of revenue from a data model that had four of them. Nobody catches it until it matters. Now, this isn't a rare edge case. Research finds that 95% of AI pilots fail to reach production. The failure isn't model quality. It's that the model doesn't know what a competent new hire would absorb in their first 3 months, which tables matter, what the business terms actually mean, which numbers are trusted, and which are legacy artifacts nobody uses anymore. The conventional response to this problem is prompt engineering. Write better system prompts. Give the agent more instructions. Add examples. Inject schema information. This approach makes sense. It's fast, it's cheap, and it improves results in the short term. But it reaches a hard limit. Prompt engineering treats context as a static text you write once and maintain manually. Your data environment, it's not static. Tables get renamed, definitions drift. A metric that meant one thing in Q1 means something slightly different in Q3 after a business restructure. The prompt you wrote 3 months ago now contains silent assumptions that are no longer true. The agent itself doesn't know that. It gives you the same confident answer it always gave, and that confidence is now a liability. Here's the right mental model. An AI agent isn't a smarter search engine. It's an autonomous actor. It takes actions. It doesn't just generate answers. And an autonomous actor that doesn't understand your business isn't a productivity tool. It's a risk. What an agent actually needs to be correct isn't better reasoning. It's four distinct types of context, and most data teams are providing, at best, one. Data context, which tells you which tables and columns to trust. Meaning context, which tells you what business terms mean. Knowledge context, which is the institutional logic that lives in people's heads but isn't documented. And user context, which tells you who's asking, because the CFO and a regional sales manager can use the same words and be asking completely different questions. Take a seemingly simple question. What are the top 10 political shows this quarter? Answering it correctly requires data context to find the right usage tables, meaning context to resolve what political and top 10 mean to this organization, knowledge context to know the fiscal quarter boundaries, and user context to know whether top 10 means by viewership, by revenue, or by engagement. That's 5 systems and 4 context types for one question. Prompt engineering can't maintain it. It degrades. What teams need instead is a living context layer, one that updates as the data environment changes, not one that waits for a human to remember to update the prompt. This is the infrastructure problem Atlan is built to solve. The failure mode is distributed metadata, each tool with its own version of the truth, none of them current. Atlan's enterprise data graph connects 80 plus sources from warehouses and BI tools to pipelines and quality systems into one living graph that reflects the actual state of the environment as it changes. On top of that graph, Atlan's Context Agent Studio runs AI powered agents that automatically enrich metadata at scale. The description agent generates semantic descriptions grounded in lineage and query history, not invented from schema names alone. The SQL Intelligence Agent surfaces the joins, filters, and business questions that practitioners are actually running against the data. So the agent knows not just what a column contains, but how the organization uses it. The README agent produces higher level documentation for assets, contextualizing them within the broader data estate. These aren't one time enrichments. Collections or curated groups of assets built automatically from usage signals, both at source and in Atlan, track metadata coverage continuously. When new assets get added or engaged with, they automatically get added to the collections and allow for immediate enrichment with just the click of a button. Critically, this context is machine consumable. Via MCP integration, any AI agent, not just Atlan's, can query this context layer before answering a question. The context isn't locked into one platform. It's available to whatever agent your organization is running. Structured context of this kind improved agent accuracy by up to 5 times compared to schema only setups. This was drawn from Atlan's internal research across 174 unique queries and 522 evaluations. That's the gap between an agent that sounds right and one that is right. The original problem isn't model quality. It never was. It's that agents are operating without the world model a competent human would carry into the same question. When teams build a living context layer, one that knows the data, the meaning, the institutional logic, and the user, they stop chasing prompt failures one by one. The agent gets things right because the infrastructure it runs on is correct. And that correctness compounds. Production usage generates feedback. Feedback enriches context. Richer context produces better agents. The organizations building that layer now will be structurally harder to catch later. The real problem isn't building an AI agent. It's giving that agent the context to be right, not just articulate. But how do you actually build and maintain that context layer at scale across a real data estate? That's what we cover next.